Alright, so we have three goals in this video, and the first thing is to find the length, width, and height of each of these boxes. Then we want to find out how many cubes would fit inside each box, and then lastly, what's the total number of material needed to make the surface of each box. So number one, we're looking at the dimensions, right? That's the length, height, and width. We'll go over that and what they actually are for each of these. And two, the cubes that will fit into it. You can think of this as the volume. And then last, the amount of material needed to make the surface of the box. And you can think of that as surface area, right? That's what surface area is, how much material is on the outer layer, almost like wrapping paper. So how do we do all of this? Well, I guess the first thing we should say is with length, width, and height, that's an arbitrary, right, assignment. Any of these directions could be length, width, or height. So here, right, length happens to be this dimension. And here, length also happens to be that dimension in that direction. And it's the same thing here, right? But we could have easily made where W, the width, is the length. And then we could have made where the length is the width. Don't worry about that. Don't stress out about it. Just pick one. In this case, they picked it for us. So all we have to do to find the length of each of these is count the distance. And I see that it goes past 1, 2, 3, 4, 5 cubes, right, in each of these cases. So in all cases, the length is 5. Right, length is 5, and the length is 5. Now, how many cubes will fit? Oh, I'm not done yet, sorry. What about the width? Well, the width happens to be in the front in all cases. And what you probably notice is that the width is also the same for all of these, right? If I count, I see that the width is 3 cubes across in each direction, right, for all three boxes. The only thing that's changing here then is the height. Right, here the height is the largest, then the height gets a little bit shorter, and ultimately goes down to 1, a height of 1 over here. So let's label our heights. Here the height is 1, here the height is 2, and here the height is 5. Now we want to know how many cubes fit in each of these. I don't like this question because you could see the amount of cubes that make up each box. Right, in this one I see that, well, for the width there are 3 cubes, right, all the way across for each length. So if there's a length of 5 and a width of 3 cubes for each length, then altogether there are 15 cubes that will fit here. So 15 cubes will fit in or make up this box. You can see them, right? There's a row of 5 here, another row of 5 there, and another row of 5 there. Here it's a little bit more complicated because it's like taking this box and then taking the total number of cubes and multiplying it by 2. Imagine if you had two of these boxes stacked on top of each other. This is what you would have. So now we have 30 cubes, and you might notice that 5 times 3 times 2 is also 30. And that's because multiplying those dimensions will help us find the volume. Here, right? Imagine if we take this shape and we double it. Well, that would get us up to about here, right? It would get us almost all the way. But there's another layer on top, so it's like taking 2 times 2.5, right, of these layers of this volume right here. So that means, well, if the volume was 30 before, it should be, well, 30 times 2.5 is what? Well, it's 75, excuse me, right? Because 2 30s is 60, plus a half of 30 is 15, is 75. And you might also notice that 5 times 5 times 3 is 75. Nice connection there. Now the surface area is always a little bit more difficult to calculate, but here we can look at the surfaces of our shapes. In the first shape over here, now we're not counting cubes but squares. There are 15 squares that will fit on the top, right? Well, 5 by 5 by 5, flat squares on the top. That means it takes 15 square units on top. On the bottom, it will be the same, 15 and 15. So we want to keep track of this, 15, right, plus 15. And then we have 5 on this side and another 5 here. 3 in the front and 3 in the back. That's 3 plus 3 is 6, plus 10 is 16. So 15 plus 15 plus 16, right? That's 46. So the amount of material it would take here to build this shape is 46 square units, square inches or something. Here, it's similar where the top and the bottom are both 15, so that's 30. But over here we have 10 on each side now, so that's 20, right? We have 6 in the front and 6 in the back, that's 12. So here we have 62. So this would take more material to make, and that makes sense because it's a larger box. Right, the larger the box, the more material it would take to build. Let me just zoom in on this last shape right here so we can finish off and find the surface area. Here to find the surface area, really, you're going to count the squares on each face. So right here, this face, if we have our dimensions, right, we said earlier, the length is 5, right? 1, 2, 3, 4, 5. And the height is 5 as well. You can see it here, 1, 2, 3, 4, 5. So this face right here is 5 by 5, or 25. The opposite face will be equal. There's another face of 25. On the top here, right, it's 3 by the length, 3 by 5, which is 15. And the bottom will have the same area, another 15. The front face here is 5 by 3 as well, or 15. And the rear face is also the equal and opposite face, or 15. So I have 4 15s, which is 60, and 2 25s, which is 50. Add them up, and my surface area is 110 squares. Not cubes, but squares, because surface area looks at square units. Alright, hope this helped.